Imagine discovering that a tiny frozen world, nearly 4 billion miles from Earth, has found a way to cool itself using nothing more than the mist hanging above its surface. It sounds impossible, yet that's exactly what scientists have now confirmed about Pluto. Even more surprising, no one believed a world this small or this cold could produce such a bizarre effect. Stay with me, because we're about to uncover one of the most unexpected discoveries ever made in the outer solar system. And before we dive in, make sure to subscribe. Here, we explore real discoveries from space with facts instead of hype, and the next revelations coming from the edge of our solar system are even more incredible. To understand why this discovery matters, we have to rewind to the beginning of Pluto's story. The tale starts in 1930 with a young observatory assistant named Clyde Tombaugh. At just 24 years old, he was assigned an incredibly repetitive task at an observatory near Flagstaff, Arizona. Night after night, he photographed the same section of the sky. Then he carefully compared each image, flipping between photographic plates, searching for a tiny object that had changed position against the unmoving stars. Most of the time, there was nothing to find, but in February 1930, one faint speck had shifted ever so slightly. That tiny moving point became the object we now know as Pluto. For decades, Pluto proudly held its place as the 9th planet of our solar system. Yet despite its famous status, almost nobody knew what it truly looked like. It was simply too small and too distant for telescopes to reveal more than a blurry point of light, leaving astronomers to rely on educated guesses about the mysterious world. Everything changed in 2006. That year, the International Astronomical Union voted to redefine what qualifies as a planet. As a result, Pluto lost its planetary status and was officially reclassified as a dwarf planet. No other world has experienced such a dramatic shift, from celebrated planet to an entirely different category through an official vote. For many people, that seemed like the final chapter. Pluto was dismissed as a distant, frozen object with little left to teach us, but reality turned out to be far more surprising. Before any spacecraft ever reached Pluto, our knowledge of it was astonishingly limited. Even the most powerful telescopes could only detect a fuzzy dot without revealing meaningful surface details. Scientists could accurately calculate its orbit because they had tracked its movement for years. Beyond that, however, almost everything remained uncertain. Its true size, the materials covering its surface, and even whether it possessed an atmosphere were questions without clear answers. Some early calculations even suggested Pluto was much larger than it actually is. Those estimates came from the belief that Pluto's gravity was disturbing the orbits of Neptune and Uranus. Later research revealed those supposed disturbances weren't caused by Pluto at all. They resulted from inaccurate measurements. In other words, many of the ideas people accepted about Pluto for much of the 20th century were built on assumptions rather than direct evidence. That makes what happened next even more extraordinary. In July 2015, after traveling through space for 9.5 years and covering billions of miles, NASA's New Horizons spacecraft finally reached Pluto. The mission had no room for mistakes. The spacecraft wasn't designed to enter orbit. It would make one incredibly fast flyby at more than 30,000 miles per hour, collecting every possible image and measurement during only a few precious minutes before disappearing forever into the distant Kuiper belt. There would never be another opportunity. Then the first data began arriving back on Earth. What scientists saw overturned decades of expectations. Stretching across Pluto's surface was an enormous bright region shaped remarkably like a heart. Unlike the heavily cratered landscapes surrounding it, This area appeared unexpectedly smooth and geologically young. Towering mountains made almost entirely of frozen water rose over 10,000 feet high. At Pluto's extreme temperatures, that ice becomes so hard it behaves more like solid stone than anything we normally think of as ice. Elsewhere, enormous sheets of frozen nitrogen appeared to be slowly circulating in giant convection cells, suggesting that heat and geological activity still existed beneath Pluto's icy crust, something researchers had never expected. Perhaps most astonishing of all, delicate blue layers of atmospheric haze extended hundreds of miles above the surface, glowing beautifully when sunlight passed through them from behind. Instead of finding a frozen relic left unchanged since the birth of the solar system, New Horizons revealed a surprisingly active world that still seemed to be evolving. Yet there was one major limitation. The spacecraft had only a single chance to observe Pluto. After completing its flyby, it continued its journey deeper into the Kuiper Belt, never looking back. Everything it failed to capture during those brief moments remained unknown. As scientists spent years analyzing the data and building increasingly sophisticated models, they realized that what they needed wasn't simply another close-up image of Pluto. Scientists didn't need another spacecraft to fly all the way back to Pluto. What they needed was a completely different approach, one that could reveal the dwarf planet's chemistry from billions of miles away without ever leaving Earth's neighborhood. That breakthrough finally arrived with the James Webb Space Telescope. Unlike New Horizons, Webb isn't designed to race past distant worlds and capture close-up photographs. Its greatest strength lies in something far more powerful. It studies light itself. By separating light into its individual wavelengths, Webb can identify the unique chemical fingerprints hidden within it, even when observing an object that appears as nothing more than a tiny speck of reflected sunlight. The telescope can determine which molecules are present, measure the temperatures of different atmospheric layers, and track how those layers change over time, all from an incredible distance. That achievement is far more difficult than it sounds. From Webb's perspective, Pluto and its largest moon, Charon, appear extremely close together in the sky. For decades, this made it nearly impossible to distinguish the heat coming from one object versus the other. Earlier telescopes repeatedly searched for evidence of Pluto's atmospheric haze, but every attempt ran into the same obstacle. The problem wasn't that the signal was missing. The instruments simply couldn't separate Pluto's faint infrared glow from the overlapping warmth of nearby Charon. Webb changed that completely. Its enormous mirror and highly advanced infrared detectors provided enough sensitivity to isolate Pluto's thermal signature with a level of precision that had never been possible before. Once Webb completed its calibration process in 2022, scientists finally had the tool they had been waiting for. The telescope turned its attention toward Pluto, and what it uncovered went far beyond producing sharper observations. Instead, it delivered an entirely new understanding of how this distant world actually works. Each new measurement revealed strange atmospheric behavior that researchers are still trying to fully explain today. If you're enjoying clear explanations of real space discoveries without the confusing technical language, take a moment to leave a like. It helps this channel bring fascinating science to even more curious viewers. One of Webb's most important discoveries focused on the same blue atmospheric haze first revealed by New Horizons in 2015. Scientists already knew Pluto was surrounded by a thin veil of hydrocarbon particles drifting high above its surface. What remained unknown was the role that haze actually played. Several years earlier, in 2017, planetary scientist Shi Zhang from the University of California, Santa Cruz, proposed an idea that sounded surprisingly counterintuitive. On Saturn's moon, Titan, atmospheric haze acts much like insulation, trapping heat and helping keep the atmosphere warm. Jung suggested that Pluto's haze might behave in exactly the opposite way. According to his theory, the tiny particles absorb sunlight during the day, but quickly release that energy back into space as infrared radiation. Because Pluto's atmosphere is incredibly thin, it cannot retain that heat efficiently. Instead of warming the planet, the haze continuously removes energy from it. Rather than functioning like a blanket, it acts more like a giant cooling system. At the time, many scientists viewed the idea with skepticism. The hypothesis was intriguing, but there was no technology capable of proving whether it was actually happening. Everything changed once Webb's mid-infrared instrument became operational. For the first time, astronomers could clearly separate Pluto's faint thermal emissions from those of Charon, solving a problem that had limited observations for decades. Using Webb's powerful infrared capabilities, a research team led by astronomer Tanguy Bertrand of the Paris Observatory performed the most detailed temperature measurements ever made of Pluto's atmosphere. Their findings, published in Nature Astronomy in June 2025, closely matched the prediction Jung had made 8 years earlier. The results confirmed that Pluto's upper atmosphere is genuinely being cooled by the haze particles suspended within it. Even more remarkably, the atmosphere measured roughly 30 degrees Fahrenheit colder than previous climate models had predicted. Researchers now believe Pluto possesses a type of atmospheric system unlike any other yet observed in our solar system. Its extreme cold is not simply the result of its enormous distance from the Sun. Instead, Pluto appears to be actively lowering its own temperature through the unique behavior of its atmospheric haze, essentially operating like a natural refrigerator in deep space. This discovery could reshape far more than our understanding of Pluto. Scientists are now exploring whether the same haze-driven cooling process also exists on other icy worlds, such as Neptune's moon Triton. Some even believe it could reveal what Earth's atmosphere looked like billions of years before oxygen transformed our planet. But Pluto's haze hides another remarkable secret. Even the tiny amount of sunlight that reaches Pluto is enough to break apart methane high in its atmosphere. Those fragments gradually combine into larger organic molecules called tholins, which slowly drift down and coat the surface in a reddish layer. New Horizons first detected this process in 2015, and newer observations have confirmed it in greater detail. Why is that important? Because tholins are similar to organic compounds that may have helped provide the building blocks for life on early Earth. On Pluto, this natural chemical factory has likely been operating for nearly 4 billion years, creating a slow snowfall of organic material onto a world far too cold for life to ever begin. The conditions are almost unimaginable. Pluto receives only about 1/1000th of the sunlight Earth does, and temperatures plunge as low as minus 387 degrees Fahrenheit, cold enough to freeze nitrogen, the main gas in Earth's atmosphere, into solid ice. For scientists, this is much more than a strange chemical reaction. Pluto offers a rare opportunity to watch ancient organic chemistry still taking place today, providing valuable clues about the processes that may have helped shape the earliest chapter of life's story on Earth. Instead of relying solely on ancient geological clues left behind on Earth, scientists can observe these reactions taking place today on another world. It's like having a natural laboratory that has been quietly running the same experiment for billions of years. Seen from that perspective, Pluto becomes much more than a distant, frozen dwarf planet. It may represent one of the best surviving examples of the chemical environment that existed long before life first appeared anywhere. The next discovery may be even more surprising. For billions of years, Pluto has been slowly losing pieces of itself. Its weak gravity struggles to hold on to lightweight gases like methane. Over time, those molecules rise through the atmosphere, escape into space, and drift away from the dwarf planet. Astronomers have suspected this atmospheric escape for years. The mystery was what happened after the gases left Pluto. They weren't simply disappearing into the emptiness of space. Something nearby was collecting them. That something is Pluto's largest moon, Charon, an icy world about 750 miles across that shares an unusually close gravitational relationship with Pluto. Most of Charon is exactly what scientists expected, a frozen landscape dominated by ancient water ice and countless impact craters. But one feature has always stood out. Its polar regions are covered by a striking reddish-brown stain, unlike anything found across the rest of the moon. For years, researchers believed that discoloration somehow originated from Pluto's escaping atmosphere, but they lacked the evidence needed to prove it. The explanation turns out to involve Charon's remarkably long seasons. Because of its tilt and its orbital dance with Pluto, the moon's northern pole remains in complete darkness for decades at a time. Without sunlight, temperatures plunge so low that the polar region becomes an enormous natural cold trap. Methane molecules escaping from Pluto drift across space, reach Charon, and freeze onto the permanently dark surface, gradually building up layer after layer of frozen material over many years. When sunlight finally returns after those decades of darkness, something unexpected happens. The methane doesn't simply thaw and disappear. But the story doesn't end there. When sunlight finally reaches Charon's frozen poles after decades of darkness, something remarkable happens. Instead of simply melting away, the trapped methane is struck by ultraviolet light and cosmic rays. Those frozen molecules are broken apart and rebuilt into heavier, reddish organic compounds that permanently stain the surface. Scientists now believe this has been happening for billions of years. Methane escaping from Pluto drifts across the 12,000 miles separating the two worlds, freezes onto Charon's icy poles, and is slowly transformed into the same type of dark organic material found on Pluto itself. Together, Pluto and Charon are locked in a quiet exchange of atmosphere and chemistry unlike anything else in our solar system. Webb revealed another surprise in 2024. Researchers confirmed frozen carbon dioxide and hydrogen peroxide on Charon's surface for the first time. The carbon dioxide likely came from underground material exposed by impacts, while the hydrogen peroxide formed as radiation continuously altered the moon's water ice, showing that Charon is far more chemically active than it appears. Now imagine standing on Pluto. The sun would look like an extremely bright star, giving almost no warmth. The sky would remain dim and bluish with a constant haze, while the frozen ground beneath your feet would be harder than rock. With an atmosphere nearly 100,000 times thinner than Earth's, survival would be impossible. Above you, Charon would never move across the sky. Because both worlds are tidally locked, they permanently face one another, frozen in the same position for billions of years. Pluto's landscape is just as extraordinary. New Horizons discovered enormous fields of methane ice blades rising more than 1,500 feet high, formations unlike anything seen elsewhere in the solar system. Scientists believe these towering ridges may cover nearly 60% of Pluto's equator. Elsewhere, dark reddish regions reveal billions of years of organic particles slowly settling onto the surface. And perhaps the greatest mystery of all lies south of Pluto's famous heart-shaped plain, where two enormous mountain-like structures tower over the landscape. Their shapes resemble giant volcanoes, complete with deep summit depressions and flow-like features. But there's one problem. Pluto has no molten rock. So whatever built these colossal formations, it wasn't ordinary volcanism, and scientists are still searching for the answer. If these towering formations are truly what scientists suspect, they are cryovolcanoes, volcanoes that erupted icy mixtures of water, ammonia, and methane instead of molten rock. Researchers still debate exactly how they formed, but both explanations point to the same conclusion. Pluto's interior was once warm enough to push liquid material through its frozen crust. That discovery fuels one of Pluto's biggest mysteries, a possible hidden ocean buried nearly 100 miles beneath the surface. Scientists haven't seen this ocean directly. Instead, the evidence comes from patterns in Pluto's cracks, ridges, and gravity measurements, all hinting that liquid water may still exist deep below the ice. If true, Pluto would join worlds like Europa and Enceladus, where hidden oceans are already considered likely. It would also suggest that underground oceans may be far more common across the outer solar system than anyone once imagined. Such an ocean could have remained sealed beneath Pluto's icy shell for billions of years, isolated from sunlight and existing under immense pressure, creating one of the most unusual environments where the ingredients for life might exist. Unfortunately, there's no mission currently planned to return to Pluto. A journey would take nearly a decade and cost billions, making it difficult to compete with closer space missions. For now, the James Webb Space Telescope remains our best window into this distant world, revealing new clues every time it observes Pluto. And perhaps the most fascinating part is that Pluto isn't alone. It lies within the Kuiper Belt, a vast region beyond Neptune filled with hundreds of thousands of icy worlds and countless comets. Pluto may simply be the first member of an enormous family of mysterious worlds that we're only beginning to understand. Beyond the Kuiper Belt lies the mysterious Oort cloud, a distant region believed to contain trillions of icy objects stretching far into interstellar space. Despite its enormous size, the Kuiper Belt remains one of the least explored places in our solar system. So far, New Horizons is the only spacecraft to have visited it, closely studying just Pluto and the small object Arakoth. That means thousands of other icy worlds remain complete mysteries. If Pluto can cool its own atmosphere, transfer material to its moon, and possibly hide a vast underground ocean, there's every reason to wonder how many other distant worlds are hiding equally incredible secrets. Pluto didn't become less important after losing its planet status in 2006. If anything, it became one of the most fascinating worlds we've ever discovered, raising more questions than answers. And somewhere beyond Neptune, countless frozen worlds are still waiting to reveal their stories. If you enjoy real space discoveries backed by science, subscribe and turn on notifications. The James Webb Space Telescope continues to observe Pluto, and every new set of data brings us one step closer to understanding this remarkable world. Thanks for watching, and I'll see you in the next video.